In this Unit 2 summary, we're going to look at the fundamental theorem of algebra. And to do this, in problem number 1, we want to look at the degree and its relationship to the zeros, which are another word for x-intercepts. So if we take a look at number 1, a few polynomials are shown below in factored form. For each polynomial, we're going to determine its degree and its zeros. So if you look at the first one, we're going to use our little trick of just multiplying the first term in each factor to help us get our degree. So x times x times x is going to give me x to the third. So our degree is equal to 3. And then remember, your zeros are what makes the function equal to 0. So what values make the function equal to 0? So for my first factor, which is x plus 4, I'm going to have a 0 at negative 4. For my second factor, x minus 2, I'm going to have a 0 at positive 2. And then for my third factor, at x minus 5, I have a 0 at positive 5. So we've got a 0 at negative 4, an x-intercept at negative 4, 0, 2, 0, and 5, 0. All right, let's move over to B. And as we're going through this, I want you guys to start seeing if you can make a connection between the degree of a polynomial and the amount of zeros that a polynomial has. So if we look at B, I personally like to distribute, right? I like to distribute that outside coefficient of 4. So I'm going to multiply it into this first factor. So I'm going to rewrite g of x as, we'll get up there, as 4x plus 12 times x minus 3. And I do this just because I think it helps me figure out the correct first term. So 4x times x is going to give me 4x to the second power. So that means we have a second degree polynomial, which basically means we have a quadratic. Now when I go do the zeros, so 4x plus 3, x minus 3, I don't have to worry about that 4 because there's no variable with it. So the only zeros I have for here are going to be negative 3 and positive 3. So I've got an x-intercept at negative 3 comma 0, and I got an x-intercept at positive 3 comma 0. So for part A, we have a third degree, right, and 3 zeros. For B, for this function, we have a second degree, and we've got 2 zeros. So let's move over to C. All right, we got a lot of factors here. We got 1, 2, 3, 4 factors. So we've got x times x times x. Another way of saying x times itself 4 times is x to the 4th. So we have a degree 4. For the first factor, we've got a 0 at negative 3. For the second factor, we have a 0 at negative 1. For the third factor, we have a 0 at 2. And for the last factor, we've got a 0 at 4. A lot of x-intercepts. Negative 3, 0, negative 1, 0, 2, 0, and 4, 0. So we'll work over on D, our last example. And again, I like to distribute anybody on the outside, like the 2x, I like to distribute into the first one. So I'm going to rewrite this guy as 2x to the second plus 14x times 3x minus 5. And then I multiply the first term and the first term to help me get my first term in standard form. So 2x to the second times 3x is 6x to the third. So this is a degree 3. And then my zeros are 2x. So I have to incorporate that because that has an actual x in it, right? x plus 7, and then 3x minus 5. So that first one is 2 times x, so 2 times what gives you 0? So you got 0 for this one. What plus 7 gives you 0? Got negative 7. And then this one, remember, you want to add the 5 over and divide by the 3. So this is just 5/3. I don't know why I wrote that there. Let me erase that guy. So I have 3 zeros, or x-intercepts, at 0, 0, negative 7, 0, and positive 5/3, 0. So if you look at number 2, it's asking what connection. So what connection do you notice between the degree? So this is important, the degree and its zeros. So I hope you guys picked up by now that if I have a third degree polynomial, so for example in A and D, so I'm going to highlight that. So in example A and example D, they're both third degree polynomials and they each have 1, 2, 3 zeros. 1, 2, 3 zeros. If you look at B, I've got a second degree polynomial with 2 zeros. And if you look at C, it's a pretty color. C is right here. It's a fourth degree with 1, 2, 3, 4 zeros. So at this point, it's safe to say that there seems to be a connection that the degree equals the number of possible zeros. So if I saw something like x to the third plus 5x, I would assume I have 3 zeros because my degree is 3. So if we go to number 3, a new polynomial function r of x has a degree of 6. So r of x is equal to 10x to the 6, dot, 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 dot. Just could be one term or many terms there. So if it's a degree 6, how many zeros would we predict? Well, if we're using the conclusion that we drew from the first 4 examples, if it's a degree 6, then I would predict there are 6 zeros, or another word for zeros, your x-intercepts.